Hello students, welcome to this video. The topic of our today's session is Introduction to Atomic Structure. Atoms are the basic building blocks of matter. We know that the matter is made up of small indivisible particles called atoms. These are tiny indivisible particles which are called as atoms. Each atom consists of subatomic particles. Now, each atom consists of small subatomic particles such as protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral in nature, and electrons are negatively charged. So each atom consists of subatomic particles called protons, neutrons, and electrons. Now, overview of atoms. Atoms are extremely small and indivisible by chemical means. We know this, that the atoms are tiny indivisible particles that the matter is made up of. Each element is made up of identical atoms unique to that element. We studied this in Dalton's atomic theory, that all the atoms of an element are identical to each other and all the atoms of different elements are non-identical to each other. Atoms combine to form molecules and compounds. What does this mean? We know that the chemical formula of water is H2O. So here 2 atoms of hydrogen and 1 atom of oxygen are combining together to form one molecule of water. So this is how atoms combine to form various molecules and compounds. Next, subatomic particles. We know that there are 3 subatomic particles: protons, neutrons, and electrons. Protons are positively charged particles, neutrons are neutral particles that are located in the nucleus, and protons are also located in the nucleus. Electrons are negatively charged particles orbiting the nucleus. This we have studied in Rutherford's model, that electrons revolve around the nucleus in their orbits. The next is nucleus. The nucleus is the dense central core of the atom. For example, if this is an atom, this would be the nucleus, which is present at the center, and it is dense. Why it is dense? Because it contains protons and neutrons, accounting for most of the atom's mass. That means the nucleus contains protons and neutrons, and these both subatomic particles account for the atom's mass. Electrons revolve around the nucleus and they don't account for the atom's mass. Why? Because they are revolving in their orbits. We do not consider them. These protons and neutrons are held together by strong nuclear forces. As they are present inside the nucleus, they are held together by strong nuclear forces. That is why the atom do not get burst. Next, protons and neutrons. Protons define the identity of an element. That means atomic number. Number of protons is equal to the atomic number. Neutrons affect the isotope of the element. We'll study about isotopes later, but just for now, remember that neutrons affect the isotope of the element. Both contribute the atom's mass number. What is mass number, atomic number? For example, we have different elements in chemistry. If I consider carbon, here we write 6 and here 12. This represents atomic number or the number of protons, and this represents mass number. And mass number is equal to the number of protons plus number of neutrons. So that is why here it is written that both, that means protons as well as neutrons, contribute to the atom's mass number, because mass number is equal to the number of protons as well as number of neutrons. Now, electrons and their behavior. Electrons are negatively charged particles and extremely light. They are found in the regions called electron clouds around the nucleus. This is according to the new quantum mechanical model of atom, which states that this is an atom and this is the nucleus. The probability of finding an electron is more here around the nucleus. And the probability of finding an electron outside the sphere is very, very less. So they are found in the regions called electron clouds. These dots are representing electron clouds around the nucleus. They are responsible for chemical bonding and reactivity. For example, Na, this has an extra electron, and Cl, it has one less electron. So when they will combine, this Na will give one electron to Cl and NaCl would be formed. So electrons are involved in chemical bonding and reactivity. Because of electrons only, different chemical compounds and different chemical compounds are formed. Now, energy levels or shells. We know that electrons occupy specific. The word specific is to be emphasized here. Electrons occupy specific energy levels or shells. For example, in Bohr's atomic model, I told you that this is an atom and these are the shells. For example, this is the nucleus, this is the K shell, L shell, M shell, and so on. So electrons occupy specific energy shells or levels, for example K, L, M, but they do not occupy any shell. That means they cannot occupy any shell, but they occupy specific shells like K shell, L shell, M shell. The first shell holds 2 electrons. That means the K shell, it can occupy only 2 electrons. Electrons fill lower energy levels first. This was given by Aufbau as Aufbau principle. What is Aufbau principle? It states that first the lower energy shells are filled and then we go further. That means electrons are first filled in the lower energy shells. That means K shell. It is present close to the nucleus, so it must be having low energy as compared to L shell and M shell. So first electrons would be filled in this shell. And how many electrons are filled in this shell? 2 electrons. And then L shell and then M shell. So electrons are filled according to energy levels. That means the one which is having lower energy, it fills first according to Aufbau. Now, atomic number and mass number. This I have already told you that atomic number equals the number of protons in the nucleus. The mass number equals sum of protons and neutrons. But atoms are electrically neutral when protons equal neutrons. That means when positively charged protons are equal to the negatively charged electrons, the atoms would be electrically neutral. Matlab no charge. Next, isotopes. So isotopes are the atoms of the same element with different neutron numbers. For example, carbon 12 and carbon 14. Carbon 12 and carbon 14. The atomic number would remain same, that is 6. But the mass number is changing here. That is, here it is 12 and here it is 14. So these are the atoms of same element, that is carbon, with different neutron numbers. If mass number is different, I told you that mass number is equal to the number of protons and number of neutrons. So if mass number is different, number of neutrons would also be different. Here mass number is 12 and here it is 14. So if I want to calculate the number of neutrons here, number of neutrons would be, this is the mass number, that is 12, and mass number is equal to the number of protons plus number of neutrons. Number of protons is 6. The atomic number or the number of protons is 6. So number of neutrons I want to calculate, it is equal to 12. So number of neutrons would be 12 minus 6, that is equal to 6. And here 6 same atomic number plus number of neutrons is equal to 14. So number of neutrons is equal to 14 minus 6, that will come out to be 8. So number of neutrons are different here. Here 6 and here 8. So isotopes are those atoms of the same element with different neutron numbers. Isotopes have same chemical properties but different masses. Here we can see that they have different masses but they would have the same chemical properties. That means carbon 12 and carbon 14 would have same chemical properties. The difference is just in their neutron numbers, or we can say masses. Next, electronic configuration. Electronic configurations describe the arrangement of electrons in the shells. We know that electrons are located in their shells, or they revolve around they revolve in their shells. So electronic configurations, through electronic configurations we get to know the arrangement of electrons, how they are arranged in their shells. For example, sodium, the symbol is Na. It has the configuration of 281. Now how we can write the electronic configurations of different elements? We know that the atomic number, so it would be written here, right? So 23 can be written as, the mass number is 23 and the atomic number is 11. Just a second. The mass number is 23 and the atomic number is 11. We will write 11 into parts. What does that mean? We know that the first shell, that is K shell, it can occupy only 2 electrons. So 2 in the first shell. The second shell can occupy 8 electrons. So how many total? 10. Just 1 electron is left. So 1. However, the third shell can also occupy 8 electrons. But we need to occupy 11 electrons. So the electronic configuration would be 2, 8, 1. 2 in the K shell, 8 in the L shell and 1 in the M shell. The structure would look like this: K shell, L shell, M shell. In K shell, how many electrons? 2 electrons. In L shell, 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. And in the last shell, that is M shell, only 1 electron is there. So this is how we write the electronic configurations of different elements. It helps us to predict an element's chemical properties. Through electronic configurations, we can get to know about the element's chemical properties. How it combines with elements. Why? Because if 1 electron is there, so it can give only 1 electron, and how it is giving an electron, that only depends what will be the chemical properties of that element would be. So through electronic configurations, we can determine the chemical properties of elements. Why did I say this 1 only and why not 2 and 8? Because 2 and 8, these shells, K and L shells, are completely filled. But the M shell has one extra electron, and to gain noble gas configuration. What is noble gas configuration? Complete filled orbitals configuration. So in order to obtain complete noble gas configuration, we need to remove this one electron, extra electron. So how this electron will combine with different elements would determine the chemical properties of sodium. Next we have is valence electrons and chemical properties. Valence electrons and chemical properties. What are valence electrons? Valence electrons are the outermost electrons of an atom. If I talk about sodium, the outermost electron or the electron which is present in the last shell is this electron. So this is the valence electron. And how many valence electrons are there? Only one. So valence electrons are those electrons which are present in the outermost shell, or they are the outermost electrons of an atom. They determine the chemical reactivity of the atom. I have already told you this. Atoms with full valence shells are generally inert. What does this mean? That if I have an atom, this is the K shell, L shell, M and N. Or let's just make up to L, K and L shell. So here 2 electrons are present, and here let's suppose 8 electrons are present. So we know that there are no extra electrons in this particular atom. It has occupied the noble gas configuration. So it is an atom with full valence shells. That means no more electrons can come here, right? Only the L shell can occupy only 8 electrons and K shell can occupy only 2 electrons. So no more further electrons can come here. So these atoms are generally inert. That means they are non-reactive. They do not react with any other element. Why? Because atoms react only when they have an electron extra or they don't have an electron. That means they lack some electrons or one electron in case of chlorine. Then only they react. But here this atom has occupied the noble gas configuration. So it does not want to react now and it will remain inert. That means non-reactive. It won't react. Next, key experiments in atomic structure. This we have already studied in the previous lecture. Gold foil experiment performed by Rutherford. He discovered the nucleus, and he also stated that the radius of the nucleus is very, very less as compared to the radius of atom. Next is the cathode ray experiment. Through this experiment, J.J. Thomson, who gave Thomson's plum pudding model, he was able to discover the electrons. So, cathode ray experiment performed by Thomson, basically, he discovered electron during this experiment. Modern spectroscopy techniques reveal detailed atomic structure. The modern spectroscopy techniques, they help us to get to know about the detailed atomic structure, how the structure of the atom is. Applications of atomic structure. Atomic structure explains chemical bonding and reactions. It is used in the fields like medicine, energy, material science. Examples include nuclear power and medical imaging. Modern view of the atom. The atom consists of a nucleus surrounded by electrons. I have told you this. Modern quantum mechanics describes electron behavior probabilistically. That means there is a probability of finding an electron there around the nucleus. Atomic structure is the foundation of chemistry and physics. Now, to conclude with, atoms consist of protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. The nucleus contains protons and neutrons, and electrons orbit in shells and specific shells. Isotopes vary in neutron count, but they have the same chemical properties. Electronic configurations determine chemical reactivity. That means how an element would combine with other elements. So, what all we studied in this lecture? First, we studied about atoms, and then subatomic particles, which include protons, neutrons, and electrons. After that, we studied about the nucleus, which is the central core of the atom. Then protons and neutrons. Protons are positively charged, neutrons are neutral. Protons determine the atomic number and neutrons affect the isotope of the element. Both contribute to the atom's mass number. Why? Because mass number is number of protons plus number of neutrons. Then electrons and their behavior. After that, energy levels, that electrons revolve in specific energy levels. K shell, that is the first shell, it can occupy only 2 electrons, and further shells can occupy only 8 electrons. Atomic number is the number of protons, and mass number is sum of protons and neutrons. Isotopes are the atoms of same element with different neutron numbers or different masses, but they have same chemical properties. For example, carbon 12 and carbon 14. Then we studied about electronic configuration, how to write the electronic configuration of different elements. After that, valence electrons, which are the outermost electrons. And then key experiments at atomic structure, applications of atomic structure, modern view of the atom, that is modern quantum mechanics, and after that, summary. I hope you understood all the points. Thank you.